It is time for our keynote this year, and it's my great pleasure to introduce Dr. Rachel Bellamy from the IBM T.J. Watson Research Center in New York, where Rachel is a principal research scientist and chair of the Computer Sciences Council. And in that role, she heads a council that manages a research portfolio of exploratory science projects. Prior to that, she led an interdisciplinary team of human-computer interaction experts, user experience designers, and user experience engineers, who have most recently been working on several of IBM Research's trusted AI projects, including two projects called AI Fairness 360 and AI Explainability 360, which I'm assuming we will learn some more about today. Rachel received her doctorate in cognitive psychology from University of Cambridge, UK in 1991, and she holds a Bachelor of Science in Psychology with Mathematics and Computer Science from University of London. And before coming to IBM Research, she was a project lead at Apple Computer's Advanced Technology Group. So a very interesting career that Rachel has to draw from. And Rachel will be speaking to us today on the topic of trusted AI. And we've reserved about 40 minutes for this session. And I suppose we have time then at the end, perhaps, for questions and a little bit of discussion. And well, without further ado, it's a great pleasure to have you with us, Rachel, and you're very warmly welcome. And we're really excited to hear your insights on this very interesting topic. So Rachel, please, the floor is yours.
Thank you. And you see my slide, yes?
Yes.
Okay, great, wonderful. So thank you. Yeah, thank you very much for inviting me. I am chair of the IBM Research Exploratory Computer Science Council. And what I'm going to do is I'm going to tell you a bit about IBM Research to give you some context. And then I'm going to talk about our Trusted AI initiative. So IBM Research has around 3,000 researchers, and we're in 19 locations and across 6 continents. And we're very proud of the many awards our scientists have received. So this includes 6 Nobel laureates. We have 10 medals of technology, 5 national medals of science, and 6 Turing awards. And while we aim to be famous for our science, we also need to be vital to the IBM business. So IBM Research collaborates across disciplines to address some of the world's most complex problems and promising opportunities. We believe that profound breakthroughs will come when businesses, governments, academic institutions, and others work together to tap into diverse points of view and expertise. Collectively, we're working to understand how systems are interconnected and the role that technology plays within them. So our research portfolio reflects that the need for science has never been more urgent than it is now. As the problems we face in the world become more complex and far-reaching, we will need to rely more and more on the world's sharpest minds to help us find solutions. And we see it as our duty to accelerate scientific progress by giving these minds access to our cutting-edge technologies and building communities to collaborate and share knowledge with one another. And this is how we will tackle the world's most pressing issues together. So within our portfolio of research that you see here, exploratory science is where we do our most basic and far-reaching research. And exploratory science is managed by 4 exploratory science councils. So we have the Computer Science Council, Life Sciences Council, Mathematical Sciences Council, and the Physical Sciences Council. And each science council curates a portfolio of ambitious research projects, and each project is expected to collaborate with universities. So I chair the Computer Science Council, and our mission is to create breakthroughs in automation, information processing, and computation that complement and extend human performance and advance society. And here is the Computer Science Council. It consists of a diverse set of researchers covering AI, systems, human-computer interaction, security, natural language processing, and cloud. And you probably recognize some of the names shown here. So we are currently doing research within 4 themes. And these themes are biologically inspired computation, socio-technical systems, towards artificial general intelligence and distributed computing. And our projects are addressing research questions such as, can we simplify computing for hybrid cloud by using a model reflecting task semantics at all levels of the computational platform? What compute platforms, tools, and languages will be best suited to the development of general AI? And what capabilities does an intelligent system need for it to empower individuals, teams, organizations, and society, and to effectively interact with people? So these kinds of questions reflect that human aspects of computing are critical to IBM's exploratory computer science mission, just as they are to each of you participating in this conference. And what's more, human aspects of computing are also critical for IBM Research's overall mission, which is, as I said, to enable technical progress that can help address those concerns that are of greatest importance to the future of humanity. And an important focus of this mission is designing AI solutions that are trustworthy. So, creating trusted AI is a societal imperative, and it's not going to be achieved by any one organization alone. And part of our IBM research mission is to engage with other groups, other organizations, and the community, and work together with these many organizations. And in Trusted AI, we're doing that, and we're working with organizations who are focused on creating AI metrics, standards, and best practices for Trusted AI, and some of those are shown here. So, algorithmic decision-making by our AI systems has profound implications for society, and it's changing how we build AI algorithms. We used to be concerned with accuracy. Everything was about, let's make it as accurate as possible. But if these AI systems are going to be affecting important aspects of our lives, AI algorithms need to be more than just accurate. We need to trust them. So what does it take to trust an AI algorithm and an algorithmic decision? We suggest it needs to be fair. It needs to be easy to understand. We need to know that it is not being compromised and is robust to bad actors tampering with it. And lastly, it needs to be accountable. People need to know the data the decisions was based on. They need to know any other decisions or changes that were made during the development of a model that might influence the final decision outcome. And we call these 4 aspects the pillars of trust. And for each of these pillars, we've created an open source toolkit that gathers different technical approaches in one place. And today I don't have time to talk about all of them, so I'm going to mostly talk about our work on fairness. I also will touch at the end on some of our most recent work on accountability and AI fact sheets. So, as we all know, AI is now in the real world. It's not just something that is happening in the lab, and it's used in many high-stakes decision-making applications. And this has great benefits. It allows for consistent decision-making at greater scale. So for example, in finance, AI algorithms are used to help decide who is creditworthy based on history of payments and defaults for people who've previously received credit. In hiring and college admissions, AI can reduce the time to process thousands and thousands of applicants by having the algorithm just identify the top few, and then those smaller number of candidates can then be reviewed by humans. And in the criminal justice system, AI is used to make sentencing more consistent. So the problem is that while there are all these benefits that we know about, there are also concerns about the fairness of these algorithms. And in fact, there have been many, many newsworthy examples of just how unfair algorithmic decision-making can be. And these examples that I'm going to talk through, some of them are in the US, but this is sort of worldwide that we're seeing these examples. So one of the early examples that made news headlines was software used to categorize photos and assign a category label to them. And this was very advantageous because it allowed text search to be done on lots and lots of images. However, it became clear that the image recognition algorithms used had serious problems recognizing people with darker skin tones. And in this case that was reported by CBS in 2015, the software applied a totally inaccurate and even worse demeaning label to photos of a Black woman. So the company was appalled and issued an apology. But there are more examples. So in 2018, image analysis used for facial recognition was also found to be problematic. This was reported by MIT News, and the image analysis used for this facial recognition software was shown to have an error rate of only 0.8% for light-skinned men, but 34.7% for dark-skinned women. So given that one of the applications of facial recognition is surveillance, the harmful consequences of software with these kinds of inaccuracies being deployed is just huge. And actually, because of the work of the Algorithmic Justice League, so that's Joy Bellamy, in pointing out this issue, many companies are now cautious about deploying facial recognition. And IBM last year abandoned its facial recognition products because of the pressure of the Algorithmic Justice League. So these organizations are having an effect, which is really good to see. So, but we have more. So image analysis used, I see what's happened, sorry. I'm now, talking about sentiment analysis. So this was also found to be problematic. So I'm sure, as you all are aware, sentiment analysis is used to determine the degree to which a phrase expresses a negative or a positive sentiment. And the fairness issue stems from sentiment scores, so they all should ideally be 0 for the statements that we have shown here, because these are neutral statements. They shouldn't have a positive or a negative sentiment. But as you can see from the scores, the sentiment service does not give these statements a neutral sentiment. So for example, I'm a homosexual gets a sentiment of minus 0.5, a negative sentiment. So this is particularly troubling because the phrase I am straight gets a positive sentiment of 0.1. So again, the company who provided these algorithms issued an apology, and they are working to create fairer AI, but these systems are out there, and there is so much work to be done. So another example, job recruiting. So in this example, the AI exhibited gender bias. The job recruiting tool was used to select candidates for further consideration, and it was biased against women. It penalized resumes that included the word women's, as in women's chess club captain, and it downgraded graduates of 2 all-women's colleges. So in this case, the company didn't actually issue an apology because after much effort to try and correct this gender bias, the executives lost all hope for the project and actually abandoned it. So yet another example, predictive policing. So bias in algorithms can also lead to these negative feedback loops. And that's what happens in predictive policing. So here the problem is that the model is predicting more crimes in areas where police have previously been sent. And that's regardless of the true crime rate. So police are then sent back to these areas. And so you get this feedback loop created. So, you know, this bias is made worse because typically those neighborhoods that the police get sent back to have a high number of racial minorities. And one very famous example of bias in algorithms was reported by ProPublica in 2016. And this is about the criminal justice system, which I mentioned earlier, because AI can improve consistency of decisions about who should get bail. So the way bail decisions are made is that when the defendant comes up for bail, they fill out a questionnaire with lots and lots of questions. And then the judge looks at the answers and the other context and decides whether they should be let out. So for some time, there's been software that can look at the questionnaire answers and give a prediction. You know, it's a very, very good case for applying AI here. That's what, you know, if you don't look at the bigger context and what bias might be, you might think. However, in 2016, ProPublica called out this algorithm saying that it was biased, and it was particularly likely to flag Black defendants as future criminals. And this is at almost twice the rate as white defendants. So in this case, the company who produced the software actually challenged the fairness analysis. They claimed that ProPublica was not looking at the right metric in that analysis. And there basically was this whole argument about what is the right metric to use to measure fairness. So before I get into metrics and how we measure fairness, first we need to understand where this bias is coming from. So machine learning by its very nature is discrimination. But that discrimination becomes objectionable when it places certain privileged groups at a systematic advantage and certain unprivileged groups at a systematic disadvantage. And bias can come in several ways. It can come in, you know, typically in the training data. So for example, the sentiment analysis models that I talked about earlier, if those are trained with documents that contain prejudice against certain religions, this is going to produce biased sentiment scores for phrases about religion. So there's also discrimination that can occur in labeling. So here an example would be a photo classification model trained on photos of people in white coats, where if the photos of males in white coats get labeled as doctors and the photos of females in white coats get labeled predominantly as nurses, then you will have a gender bias in your trained model. And another source of bias is under or oversampling. So here for facial recognition, if we have insufficient samples of non-Caucasian faces in the training data, then this can lead to biased models. So bias in data leads to these, you know, unfair decisions made by models that are unfair. But how are we going to decide what's fair and what's not fair? So you know, I spoke about the ProPublica case for, you know, deciding whether defendants should get bail. And there was an argument there about what was fair and what was not fair. And it's really difficult because there isn't a universally agreed upon notion of fairness. So even in the legal domain, we've got two different notions, disparate treatment and disparate impact. And there are also philosophical and political viewpoints about fairness, such as equality of opportunity and equality of outcome. But we really need, if we're going to make AA fairer, to be able to measure fairness and really deeply understand what we're measuring. So I'm going to give you a very simplified view of some of fairness metrics with this simple situation that I've set up here. And we're considering group fairness. So group fairness is where we're measuring equality across groups defined by protected attributes. So that's such as, gender or race. And we have this really simple situation set up. So here we have people, let's say they're applying for a loan. And we've got two groups. Exactly half of the people who are applying for a loan fall into the unprivileged group and half into the privileged group. And we can say that the privilege could be defined by sex, with males being privileged and females being unprivileged. And the algorithm is predicting whether this person applying for a loan is likely to default on the loan and not pay the bank back. And in the case of loan applicants, those predicted unlikely to default are given a loan. And these are our positives here. Those refused a loan are our negatives. So of those people given a loan, some will still default on the loan. And these are our false positives. And of those people denied a loan, some people, if they had been given a loan, would have paid it back. And these are our false negatives. And so in this situation, we have a balanced number of true and false positives and true and false negatives in both the privileged and the unprivileged group. But this is not always the case. So here, we have the same number of unprivileged and privileged, but as you can see, we have a different number of a different number of true positives and a different number of false negatives in our unprivileged to our privileged groups. So how does this affect bias, and how might we measure fairness in this very simplified situation? So in the law, the measure often used is disparate impact, shown here. And for fairness, where the unprivileged and privileged groups would be treated as equal, disparate impact, disparate impact here should be 1. So a disparate impact of less than 0.8 or 80% is the original definition of discrimination in hiring. So in the example shown here, let's pretend we're predicting who should be hired. And if we had 7 out of 10 of the privileged group hired and 6 out of 10 of the unprivileged group hired, the ratio of these two numbers gives us the disparate impact of 0.86, which would be discriminatory at our 80% threshold. So this metric focuses on the proportion of each group who receive a favorable outcome. This metric would not be good in our recidivism case, and that's because there you want to pay attention to the errors in the favorable and unfavorable outcomes. For recidivism prediction, you need to ensure you don't have disproportionate numbers of your false positives and false negatives, because you don't want the people you're denying bail. You don't want to deny bail to people who would not commit another crime. And you also don't want to let people out on bail who would commit another crime. And you want to make sure you're fair across your groups. So recidivism, you could use, for example, average odds difference, shown here, because that takes into account equality in the false positives and negatives. And when it matters, if your model gives all groups the same opportunity, you don't want to deny a loan to a greater proportion of the unprivileged group, for example, you can use equal opportunity difference. And, that's equal opportunity difference is the ratio of true positives to false negatives for the unprivileged group minus the ratio of true positives to false negatives for the privileged group. So what I showed you there was some very simple ways of measuring fairness. But once we've measured fairness, we, in our algorithms, we also need to be able to fix any bias that is shown. And this is not always easy. So for example, we could make the model fairer by removing race as an attribute. But if we do that, it might not work because race is often correlated with other attributes. So in the past, companies actually took advantage of such correlations when they used a practice known as redlining. So in this case, banks would redline certain zip codes on a map, which meant they would often not lend to people in those zip codes. And because in the past, zip code was typically correlated with race, this resulted in discrimination. Thankfully, this has since been made illegal. So there are 5 bias mitigation strategies that are popular today. So the first one is fairness through unawareness, which is the example I just discussed, where we exclude protected attributes from our model. But as I said, this is not a great approach, both because of the correlations between attributes, but also because sometimes it can be helpful to have those protected attributes there for removing bias. So if we had our loan prediction example where you're predicting whether somebody should get a loan or not, and if living in some zip codes could be a strong indicator of how likely someone is to default for white Americans, but quite a poor indicator for Black Americans. So in this case, the protected attribute of race can actually be helpful when you're building a model to learn this statistical interaction between race and zip code. And using it can result in a fairer model. The second, and probably, this is the go-to strategy, you should consider collecting better data. So, the main source of AI bias is data bias, and we need to carefully examine our data for potential labeling biases and our data collection methodologies for sampling biases. And I cited this paper here. This was a survey conducted by Holstein et al., and it indicates that the support that practitioners of machine learning most urgently need is some kind of scaffolding for fairness-aware data collection and test set design. So that's a great area for future research. So the rest of this list are bias mitigation algorithms that map to different places in the machine learning pipeline. So here's our machine learning pipeline, and we show the stage at which different algorithms can be applied. And so with our pre-processing here, we're aiming to statistically transform the existing data to make them fairer before using them to train our models. With in-processing, we actually train using a bias-free classifier. And with post-processing, we transform predictions of the model to make those fairer. So that happens after you've got a trained model. So the choice of which bias mitigation algorithm to apply is partly based on the developers or the user's ability to intervene at these different parts of the machine learning life cycle. So if you can modify the training data, then you can do something as early as possible with fair pre-processing. If you can modify the algorithm, then you can use fair in-processing to mitigate bias. But if you can, if it's a black box and you can only deal with the predictions that are coming out, you're going to have to use a post-processing bias mitigation method. All right, I'd now like to show you the AI Fairness 360 toolkit, which we created. So this is an open source toolkit, and it has over 70 metrics and 10 bias mitigation methods. And we created this because we were looking to gather all the fairness metrics and mitigators into one place. And this is part of our approach to doing this kind of research, where we want to create this open source community that can work together to address algorithmic bias. So I'm now going to stop sharing this and go here. All right, so hopefully you can see, yeah, you can see my screen still. And so here we're at the AI Fairness 360 Toolkit. So here's the URL. And, you know, basically you come into the toolkit and you can go and get, there's Python code and R code for these metrics and mitigators. And you can also go and look at the API docs if you want. Typically when we come in here, in this first page, you get to see various introductory materials. There are also detailed tutorials with in Python notebooks here. And then we take you through, there's lots of material to, you know, for learning about the different bias mitigation methods and metrics. So typically what you might do is, you know, look at the web demo first. And this takes you through showing how you might mitigate bias throughout the pipeline, as we talked about. So first of all, you start with your data. And maybe, you know, we're going to, or maybe I'll do the compass, the recidivism. So this is predicting, you know, who's likely to commit another crime if they're let out on bail. And it tells you, you know, that it's got protected attributes here, sex and race. And it says the privileged is female, unprivileged male for sex, and for race, privileged Caucasian, unprivileged not Caucasian. And, you know, we're most interested in race, but we're going to choose this and look and see what happens. So we're checking for bias. All right, and then we get our fairness metrics, and let's have a look. So we're interested in race here. And as you can see, it tells us that our accuracy is 66%. So this is without any mitigation. So not great, but okay. And bias against our privileged group is detected in 4 out of 5 of these metrics. So you see these here all have bias as indicated. And so then what you want to do is, so let's think about, okay, we're going to mitigate, and we want to mitigate as early as possible. So here in this demo, you know, we show you, you know, that you can do this pre-processing mitigation on the data. Here's an example of training a bias-free classifier. And here we have, you know, your post-processing mitigation on the predictions. But we're going to just look at reweighing here.
Hey, Rachel, this is Anita. Sorry, can you make the screen a little bigger?
Oh, I can.
Thank you.
Does that help? Maybe not.
You make the fonts a little bigger.
Okay, okay.
If not, it's possible. If not, it's okay.
Yes, I can. Is that big enough?
Awesome. Thank you. My wee guys.
Okay, so now we did mitigation, and you know, we're interested in our protected attribute race, and we see our accuracy is unchanged, which is great. We actually do, you know, we're trying to balance accuracy against fairness. We don't want to totally compromise accuracy when we go to a fairer result, but we're very pleased to see that, you know, we have now for all of these 4 metrics, with our application of that bias mitigation, we have managed to produce a model that is fairer. So that's great. So that's, and you can go back and you can play and look at the others. But in the interest of time, let me show you what else is here. So, you know, we also have various resources. So, you know, an overview, very useful is this glossary that defines lots and lots of terms that are used There's guidance about when to choose which metric and mitigation. And then there are the Jupyter notebooks that contain these tutorials where you can actually get access to the code. And another thing that for you to know is that we also have a Slack community where you can go and you can ask people questions, share your findings, even better, and just participate, and so that we can grow what we're doing. And you can request an invitation to that community here. What else do we have here? Another thing that is here is, so at the beginning, I told you that we've done several of these toolkits. So this is fairness. There's also a toolkit for explainability, one for adversarial robustness, and one for transparency and governance. And actually, I'm going to go back to the presentation, and I'm going to, which I've lost behind here. Here we go. I'm going to, okay. Show you a bit about I wanted to give you a little taste of the work that is being done on governance and show you some about our AI fact sheets. And this is a video that was put together by IBM Research's media team. So I thought it'd be nice to show this to you. Here you go.
Businesses are increasingly adopting and deploying AI to...
Oh, okay, let me start again. You have no sound, yeah?
Yes, that's right. The sound broke off.
Yeah. Okay, let's try again.
Automate businesses and IT processes, gain new insights through data analysis, and better engage with and serve customers. Yet, as AI adoption takes off across industries, the biggest obstacle to widespread deployment is trust. Trust, along with language and automation, are the critical ingredients needed to scale AI for business. But how can you really trust AI? First, it's important to consider how AI is built. AI is managed across a life cycle, a sequence of steps from preparing and building models to deploying and managing them out in the world. These steps must all be carefully monitored, and guardrails must be put in place. At IBM, we call this process AI governance, which is designed to help businesses create policies, assign decision rights, and ensure accountability. With proper governance of AI, we can prevent undesirable outcomes, including models unintentionally harboring bias, being trained with improper or unapproved information, or even having unexpected shifts in performance. But how do we get there? One major challenge to date is that the monitoring and documentation of the AI model lifecycle is performed manually. This requires substantial expertise and can increase the risk of incorrect information. Enter IBM Watson's AI fact sheets. Born out of IBM research and built for a hybrid cloud world, AI fact sheets will automatically capture key information on a model's performance and automatically create reports to support transparency and compliance. Drilling down deeper, AI fact sheets are customizable for varying audiences, external and internal. Facts collected can vary across industries and use cases, and reporting views can be customized, providing people like the business owner, data scientist, model validator, and model operator unique reports with insights tailored to their specific needs. Like nutrition labels for foods, fact sheets would provide important information about AI models, such as its purpose, performance, datasets, and more. Model facts that are key to building consumer and enterprise trust in AI services across the industry. So what new capabilities will AI fact sheets offer businesses? Policy creation, the fact sheet template. Creating a template allows organizations to define the information collected on an AI model, such as how the model was created, tested, trained, deployed, and evaluated. It can also standardize what data can and can't be used, what regulations such as GDPR or company policies need to be accounted for, and many other factors. Automated data capture, model facts. To date, documenting an AI model's performance has required extensive amounts of time and resources, often leading to quickly outdated and irrelevant reports. Soon, organizations will be able to continuously and automatically capture metadata, model facts, across the entirety of the AI lifecycle. Automated reporting, fact sheet. With automated data capture, the fact sheet will provide real-time reporting on the performance of the model, along with custom metrics. The fact sheet can be tailored to the needs and preferences of different users and audiences, enabling collaboration across varying levels of technical expertise that otherwise wouldn't be possible. As with all IBM Watson technology, AI fact sheets will be open, built to run anywhere, and can help organizations manage risks across any hybrid cloud environment.
Okay, so that was a little taste of, one of the other pillars of trust, which is governance. IBM last year donated the trusted AI toolkits to the Linux Foundation. And the idea here is that this will further the mission of creating responsible AI-powered technologies and enable the larger community to come forward and co-create trusted AI. So, please go and look at what is happening there. And if you're interested, join that community and participate. And finally, this work isn't done by one organization alone or even one person alone. It takes a lot of people, both inside and outside of IBM. And here are just some of them. And, every single one of them and more are working. And we need even more people to work towards creating trusted AI. So thank you.
Thank you, Rachel, for this most captivating talk. And please, everyone, join me in some virtual applause for our keynote speaker. And now we have some time for questions. We are a little bit into the break, but I guess that's fine. I'd like to remind everyone that we're recording this session, so if you prefer not to be recorded, please write your question in the chat. I know that some have already asked something, but if you're fine with appearing in the recording, just open your microphone and ask your question. So please, the floor is open for questions now. And I see Rashina's hand going up.
Hey, thanks. Thank you, Rachel, so much for that really insightful talk. And also thank you again for accepting our invites for this keynote. We are very, very pleased you're here. Okay, so you talked about collecting better data for bias mitigation, which obviously makes a lot of sense. My question is, should we be collecting facts for the world that exists, or should we be collecting data for the world that we want to create?
Very great question, yes. So one of the issues is that when we look historically, and so we look at the data that we have available in the historical record, because unfortunately our world has not been a fair one till now. We have, this is an issue. And so, if we could have methods where we could create fairer data sets, which is what the pre-processing mitigation algorithms are doing, then that is, those methods would help us create better data. The other thing I think we can still, even with existing data, we can do better. We tend to collecting good data is really hard. And I would encourage anybody developing a model working with a stakeholder who, actually can help possibly collect better data and give the insights into the different communities. So I think that there is a lot of work that can be done in defining these data collection methodologies. And also, I come from a background in participatory design. So of course I think that, but I think that it's the right way. Basically, we need to extend, who is involved here and who's getting to understand what the data is and what's in there, and can bring their understanding of an area and help us ensure that the data is as fair as possible. So.
Awesome, thank you so much.
I see we have a question in the chat from Alexander. It appears that a lot depends on the creators of AI, the organizations running it. Do you have any insights or suggestions as to how people affected, for example, by unfairness can get involved?
So, yeah, this is another great question. The work, so I did talk about the work of the Algorithmic Fairness League, who actually had a great impact on the facial recognition, what's happening with facial recognition. So that was a set of people who, cared about this, getting involved and approaching the companies and saying, excuse me, what the problem is. The other, I also encourage you to go and participate. There are now, if as a developer, to participate with the people like the Linux Foundation, but also with, finding stakeholders who you can bring into the conversation. So including more diverse voices. I know that, this is something that IBM is working on, how to get more people involved in this conversation and be able to impact the development of the technologies, even when they're not developers. They're not, so the sort of explainable AI there is very important. You need to be able to explain to all the stakeholders what's happening, and we need to be more transparent. So.
And we have noticing an earlier question here from Sridhar. Excellent resources. Just curious to understand, what are the strategies to get fair data without violating privacy?
So another great question. I don't know all the strategies to get fair data without violating privacy. I'm going to go back on saying, be very transparent about what data you're collecting. We shouldn't, I actually think that privacy is key. I don't think, everything that's being done to increase privacy in data collection is very important. That said, the techniques for balancing, basically applying these mitigators on your data sets is one way. Just getting involved in the conversation about when does it even make sense to create a model and use a model. I think that we're not even having those conversations, because if we can't make our models fairer, and if the impact of the model can have causes that can lead to worsening our societal inequities, then we should be questioning whether it's an appropriate application. And that's why another reason, I keep going back to the same thing, another reason why you want to include diverse voices in the design of any solution, because you need to ensure that you are not, it might be that you cannot collect fair data in a situation. And then I think you need to really question whether this is an appropriate application.
All right, then I think you might have answered Paul's question in the chat. Are fair data sets even possible in a fundamentally unjust society where virtually everyone harbors unconscious biases? And I think you kind of answered that question in a way, perhaps not.
I would just like to, can I just, because I think this is our unconscious bias is something that every single one of us, there is an awareness in the research community of unconscious bias that is much greater than it was 5 years ago. So, however, in society, that awareness is not as broad. And so anything any of us can do to help people see their unconscious biases. So this is not outside of AI now. This is just improving society, So I think that's on each one of us. Each one of us who sees that we have these bias, we need to work out, what in our small sphere, because each of us, there's not only so much impact that any single one can have. We need to do what we can. And hopefully by doing that, things will get better.
Thank you. A hopeful outlook. Also a small note for potential future chase papers. So when do we create a model? When should we create a model? I'd love to see some submissions on that in the future. Unfortunately, we have to break now. Rachel, it's been a very interesting talk, and thank you so much for joining us. And you're of course invited to the rest of the program as well.